Well, hello. I'm going to use a little bit of logic programming today in R and fiddling with some CSV files. So they're the type of things that spew out of Excel at random points of time. I'll show you the files. They're not especially big. There's one called bigfile.txt. It's 120,000 lines long, and it's about, I don't know, 15 variables across as this comma-separated file. And this is another file which has similar ID numbers as the first line, and it's a file of, I don't know, about 80,000 long. And those are the ones we'll be working with. So what I'm going to do is use R to clean them up a little bit and then check them and do a little bit of bizarre programming here and there. Okay. So first of all, I'll do the famous file chooses to get them. Here we go. We kind of go over here and I'll say big file. I want to know the name of it. And then other file I will get right there. Okay, let's see what we got. For instance, yep, that's pretty darn exciting, isn't it? Well, I will read them both into R. They have headers, so to remember that. The as is, by the way, is a little bit interesting. What that's going to do is keep it from converting columns of strings to factors, because I want to keep them the same value they are. So, okay, here we are. Let's take a little look at that. Look at the tops of them. There's some an ID code. There's 8 variables. These are actually proportions that can add up to more than 100. This is an age, sex variable. Okay, add red as in a data frame. Well, I'll look at the end of the other file. Well, it is the other file. There's the end of that one. Okay, that has a same ID and a potential other variable that can be merged in. Let me look. I'm going to just peek at the first line. Might as well just look at the first line and apply type of to each. So sapply will take every item in the first line of big file. So here we go. And we'll take type of it so I can see what types they are. Ooh, look at that. Integers, characters, integers, characters, integers, integers, integers. Yep, that looks good. Hey, it certainly isn't any factors. Same thing could go with other file. So sapply is kind of like a loop. It applies to every item in this vector. It's going to apply a function, whatever function I put here. Ooh, wow, that's pretty good. Okay, let's see how big they are. Oh, that's big. 120,000 by 15. This one's not so big. 83,023 by 3. Now what I want to do is pull out a separate data frame. I'm not going to look at it, but one thing is this first file is not really supposed to have duplicated entries. So I would want to take a look and see what they exactly meant. They could be the same individual being sampled 2 different times, which could be a problem, or could be that the code names weren't coded right. So in any event, I want to pull them out. So what I'm going to do is use duplicate. Which will show me every ID that is duplicated. However, it doesn't show you the first time they show up, just the duplicates. See, it's and yeah, the first few weren't duplicated. I want to see, this is an old trick, since there's 0, 1, saying sum will actually count up how many duplicates there were. 5,924. Okay. So I actually want to do one thing to clean up that first file. I'm going to order it so that it's by the ID column. The ID columns are all sorted. May make things run faster. Okay, I'll use order, which actually gives me an index that can reorder my variables. It's going to be based on the ID. That should take a few seconds to run. Ah, there it is. Okay. And then I'll recode it as ordered. Okay. That's going to give a data frame that is ordered by ID. Let's take a look here. Head, big file, I'll bet it is. Yep, there looks like the ID is in order, starting with A. Alright. Yep. Okay. So now I want to do something else. For fun, that took care of the IDs. And I want to now look at various variables. I want to look at G1 through G8. And what I want to do is see what sort of values they are, including NAs. But first I'm going to do this the most obtuse way possible just to show something. And then I'm going to show a faster way to do the same line. This is a really neat line. Apparently, essentially, I'm programming on the programming language. What am I doing here? Let me show you. Okay, so what I really want to do is do tables. Table of big file dollars. I could have attached it too, but let's not think about it. Okay, so there's a big file that says how many zeros, ones, and twos. If I had attached the data frame, I could have just immediately talked about their the variable names without saying big file dollar, but I don't want to do that right now. So look, I do a little loop, and this is just mainly for fun. So what I do is I have the computer create this thing, big file $G1, using paste. So I'm pasting the word table, big file $G, and then I put the letter I, which is going to be running from 1 through 8. So it's sequentially going to create the string table big file $G1, G2, G3, G4. I had to do this so that would put the G right next to the number. This pastes them together. It's text. Parsing is going to run the parser. So that R will parse this as a statement, and then it'll evaluate it, which means just it'll run R on it, and then print will print out the output. So this is the tables for G1 through G9. I could do this even a little more fancier and use an important side command that's really handy in tables. One thing tables don't do is show you the missing values, but you can say use NA equals always, and it'll show you how many missings there are too. So what I will do is do the same loop as before, but in the paste I'll paste in use NA equals always. That's one kind of a pain to do though, because look, when I said use NA equal always has quotes around it, so I had to do backslash quotes because that's the only way to put a quote in a quote. But so I'm basically pasting together this expression by hand. I mean, hand assembling it in a paste and then parsing it. And so I can see I have missings, a few hundred missings in every one of those variables. It's going to turn out I don't really want to clean the data for that. Later analysis, they'll just be considered missing. Now, why this is kind of silly, I wanted to show the paste and eval, but lapply for list apply would have done that a lot more easily. Look at this. I could just say big file. Let's do big file. It's a data frame, so it's a list. So I could take items 3 through 10, which cover all of the ones I want. And then big file or lapply will apply a function to each one. So here's my function. Function of x. This is called an anonymous function, which I'll talk about later. Table x use NA equals always. Oh, come on. There they are. I think that's the same. Oh yeah. Yep. So that was a little easier, but what can I say? Being able to have the computer assemble variable names and statements can come in handy sometime. Okay, now I'm pretty close to done with my checking. Now I want to check x1, x2, and x3. Again, I should show you what that table expression does. So table, let's see if I just put some values in here and do my old favorites. NA, NaN, oops, inf through 2. If I do that, notice infinity is considered a valid value, so it shows up there, but the missings don't. So as I mentioned before, you'd have to do exclude null. That means nothing is excluded at all, including NaN. So this shows a full table. So I'm doing exclude equals null instead of the use NA, because this will also get the NaNs there. So okay, so that's really what I want to use. So I will get bad x's. This is the bad x value are going to be, okay, row sums. So remember what I said could be wrong with that. Those three numbers could add up to more than 100. Oh, hold on. Yeah, I do want to make sure everything's between 0 and 1 in those, so hold on a second. Table x1 oops, big file. Okay, no NAs, numbers running from 10 to 100, they're percentages, so those are fine as far as I can tell. Let's see, x2, not bad. x3, yeah, that works too. Uh-oh, wait a second, there's some x3s over 100. That's a problem. And also, if they sum to more than 100, there's going to be a problem. So let's look, table. Now, mind you, if there's too many possible values, table is not very handy. How do I want to do this? I'll just pull out the bad numbers. So, bad x's so are going to be either row sums. So what I'm going to do is I'm going to take big file. Let's get the ones that go with x1. There's many ways I can do this. Remember, we can index by logicals. We can index by names, which I'm doing right here. We can index by positive numbers. So, and negative numbers. So there's big file. There's the three of those. And I'm going to say, what I do is I'm going to pull off those three columns. I'm going to use row sum, which will sum up each row of it and give me a vector. And I want to see when if that's less than 100, there's trouble, because they have to add up to at least 100. Then I say that's a problem. Or if big file $sign x3, we know some problems with that one too, where they had some over 100. Okay. Oh. Row sums, sorry. Okay. And how many of those bad values are there? 1,306. I'm going to toss them out later, but those lines, that many lines. But yeah, let's look. So for each line, it tells you whether it has a bad value or not. So the first 5 or first 6 don't have bad values. Okay, so for now, that's all I'm going to do with those. I could pull them out and examine them if I wanted to. Oh, why not? I'll just show I could easily make a new data frame just containing the big bad values for later viewing pleasure. So If I want, oop, uh-oh. Why can't I spell? Bad X's in big file. Oh, I didn't capitalize the big. Okay. I deserve that. There we go. Okay. So yeah, ooh, X1, X2, X3, these are definitely summing to less than 100. That's their problem with this set of them. But I'd have to go and look and see what's so unusual about those IDs. Okay. Well, we have age and sex variable at the end. We should take a fast look at that with table. Okay, no problem there. Age. Now I know for a fact that nobody in here is over about 80 something. And there may be NAs that got put in as a missing value. So I'm gonna take a look here and see. Yep, they got a bunch of NAs, and then we got 2299s, which were a missing value too. Oh my gosh. So what I want to do is I want to create a clean file. I want no duplicated IDs. If the ID is duplicated, I don't want it in there. I don't want any sum of xi's over 100. Actually, now I think about it, I don't want any x3s over... No sum of xi's under 100. No x3s over 100. No NAs in the x of I. I don't want any missing or 99 ages. So, can I do that in one statement? Let's try it. I'll call it good lines. First of all, not big file. I'm using lots of parentheses because I don't trust precedence. Okay. First of all, if the idea is in one of the duplicate IDs, I don't want it. So it better not be in one of those. And it better not be a bad ID. What were those based on? Oh, that take care of the sum of the x's less than 100 and x3 bigger than 100. So that's good. Okay, I'll clean those out. I want IDs, the ages to not equal 99. Oops. And I also want the ages to not be missing. Does that do it? My gosh, that does it. I'm going to call a new data frame clean big file. Yeah, I sit up all night trying to think of good names for these things. Good lines, comma. And that should do it. Now let's see what dimension I get. Dim. Okay. Yeah, I ended up with 106,000 lines. That's not bad. Not that this will be at all enlightening, but here's the first few values. Okay. Now, finally what I'm going to do is, I have another file called other file. And the other file has IDs that could match. And it has some additional data. So somehow I'd like to take the data from other file and put it in the clean big file, and I'll do that using a really simple database command called merge. Let me make sure there's nothing horribly wrong with other file. That's not bad. That's not bad. Okay. What is in other file, by the way? Yeah, there's ID2. ID2 is the name of its ID. Unfortunately, big file has ID as its ID. So to match those are the two that I'm going to match. So anytime there's a value that matches in both files, it's going to merge those two data frames. So let's do it. Merge file is going to be merge of clean big file with other file. Now the ID that's going to be used for matching in the first one is ID. In the second one, it's going to be ID2, and I think that does it. Oh, here we go. Okay, 80,000 some lines. You'll notice, here we go. We have our ID is the same on both of them. And here's the G9 attached to each proper data case. So, yep. And now has 17 variables. It takes the old one's row number, by the way, and attaches that along with the variable. Okay. For one last thing, I'll show a simple method if you just don't want any missings at all. It's complete cases. Watch this. So if I go, and I did remember leave some NAs in the Gs. Let's say I've completely changed my mind and I don't want those. What this is, complete cases is going to give the line numbers of lines that have no missing values. Now I'll take the merge file I just made, and I'll only take the complete lines. Okay. Alright, looks like around 78,000. Did it really work? What did I make the merge file out of anyway, of the original merge file? Clean big file. What did I make clean big file out of? Good file. Out of big file. Okay. I'm just curious. Did I really get rid of all the NAs? Is NA complete merged file? So it's going to scan everything in the columns. Oh, is that? I'll just go anywhere. So is there NA anywhere? Nope, there's not a single NA anywhere in that entire file. So that showed a few things. I did sapply and lapply, which are simple ways to apply a function to either a vector or a list. I showed merging and duplicate and unique, ways of combining files and ways of checking whether IDs are duplicate or unique. That's a duplicate right there. That's kind of redundant what I just said, but and some logic statements. And what else? Lots of stuff with table and a little bit with paste and evaluations. So evaluation, pasting, together statements. Anything else especially interesting? Reading in data by file choose CSV files. And I think that's probably all I want to say about data cleaning and merging. All right, thanks.